Salam and a very good day to everyone. So today we will continue our lessons about the engineering management and safety. Today we will discuss the engineering economic decision making based on benefit to cost ratio. Benefit to cost ratio or BCR is a technique, okay, uh, to utilize the ratio of benefit to cost, either calculated using present worth, okay, either present worth or annual cash flow. So we can choose which method that we want to calculate. This technique used to determine the public interest project or infrastructure, okay, by using a formula BCR equal to benefit minus the this benefits based on the costs that occurred by our government. Mostly, the intentions of BCR calculation is to justify the benefits of the spending costs of government, okay, to public and society. The spending in public interest is such as public transport, stadium, railway system, school, telecommunication provider or infra, safety, military, and also public health. The example of BCR calculation is applied for constructions of four-lane highway Pekan to Kuantan, okay, as example, or new township facilities and infrastructure at Gebeng, Kuantan for industrial zone, or a new highway from Desaru to Pasir Gudang, or a service of interkota buses from town of Kuantan to Pekan. Okay, let's see the first example of BCR calculation. Calculate the BCR of a road improvement from Pekan to Kuantan at Pahang as given information. Okay. Use interest of 5% because our country's growth rate GDP at 2017 is 5.9. So we use 5%. And then we also having informations from respected data collector, okay, about the monetary impacts and other impacts of road user effects, okay, regarding of the vehicle operating cost, time cost, accident cost, and also emissions cost uh, for road user effects. So by using this data, we can calculate, okay, the road user cost per year, okay, from figure 5.1 here. And then also uh, if we use 4-line basic road without a toll, we will use, okay, road user cost per year around 450,000. However, if you use 4-line with a toll fencing road together with R&R facilities, okay, the road user cost will become 200,000. Okay, and then there is a possibility of maintenance cost per year 35,000, okay, for 4-line basic road without a toll, and 55,000, okay, for a toll line. And the initial cost for basic road without a toll is 10,000, okay, 10,000 K and 15,000 K if we make a decision that we want to have a 4-line with a tall fencing road and also R&R facilities. Okay, let's see the solution. Okay, as usual, we need to develop our cash flow diagram. All right, the initial cost for 4-line basic road without a toll, the initial cost will become 10,000 here. Okay, this happened at present time, and then we are required to pay 35,000 each year as our maintenance, and then road user cost per year is 450,000. Okay, this happened up until 30 years. And then if we develop a 4-line with a toll, okay, we need to pay 15,000 K, okay, in the present day, okay, for the development costs, and then 55,000 for the maintenance costs each year. And then we also need to pay for the road user cost per year, 200,000 per year for 30 years. Okay, once we got this cash flow diagram, then we can calculate the BCR. Let's see the solution for the example one. Due to the annual cost A of 4-line with a toll, okay, represented by T here, is lesser than 4-line basic, okay, represented by B here. So the calculation will be start with T deduct B, okay, and then from here we will see that 200,000 minus 450,000, we will get negative 250,000. However, because of the negative value, the arrow was reversing from downward to upward. Okay, it become like this. Okay, to become upward, and then after that, another calculation we made is 55,000 minus 35,000. We will get 20,000. Okay, and then because of the positive value here, so the arrow will stay downward. Okay, no problem, stay downward. All right, and then after that, once we get this cash flow diagram, so using this cash flow diagram, we will calculate our BCR based on T deduct B. Okay, so 250,000 here. Okay, and then 5,000 finding A when you knew the P, because this calculation is based per annum base. Okay, so 5,000 multiplied by finding A when you knew the P, because this 5,000 here is represented by our present value or P. So we need to change this P to become A. So this 5,000 multiplied by finding A when we knew the P at 5% for 30 years. Okay, and then plus 20. 20 is derived from here. Okay, and then once we got all this value, we'll see that our BCR of T deduct B or T minus B here, we got 0.724. So our understanding is for each ringgit that spent by our government for project T, public is benefits 0.724, which is less than value of 1. So project T should be rejected. Okay, instead project B is better than T and should be constructed. So the government should choose project B, okay, as a chosen project. Okay, okay, let's see the second example of this BCR. Right, so during a rainy season year 2014, the main highway from Kuala Lumpur to Kuantan was not accessible due to the flood which submerged several locations. Okay, road 1 and forced the road to be closed. Okay, this is road 1 from KL to Kuantan. Alright, The situation was whenever a second route by using previous federal road from Kuala Lumpur, Lanchang, Temerloh, Gambang, and Kuantan also get flooded. Okay, here all passenger, raw material, or document were stuck. Finally, road user from Kuala Lumpur was deviated to an alternative route. Okay, from Kuala Lumpur to Seremban, Kuala Pilah, okay, and then Muazzam, and then lastly arrive at Kuantan. Okay, the third route there, which distance almost 150% more. Another option available also from Kuala Lumpur. Okay, use the same route here, Kuala Pilah, but they use the Luban Condong here, and then from the Luban Condong they will go to Pekan. Okay, Pekan and then Kuantan. Okay, which act as alternative route 4. Alright, both routes were jam-packed by heavy and light vehicle during the rainy season. As a result, both routes were maximally optimized, which potentially creating dangerous occasions and increase the accident tendency. After the monsoon season finished, a proposal was made to upgrade both alternative route 3, okay, route 3 and route 4. Alright, this step taken to ensure this alternative route is adequate and prepared for higher traffic congestion if anything happened at route 1, okay, and also route 2. So the cost estimates is as given information. Use interest I equal to 5% because our country's 2017 GDP growth rate is 5.9%. Okay, let's see the solution. If government make a decision to develop 4-line basic route without toll from Kuala Lumpur to Kuala Pilah to Mozam and Kuantan, the initial cost will become 90,000 K, and every year 100,000 K will be used to become maintenance costs. Okay, and then we expect that the road user cost per year will become 1,500 K, right? And if our government make a decision to develop 4-line basic road without a toll from Kuala Lumpur to Kuala Pilah to Leban Condong, Pekan and Kuantan, okay, the initial cost will become 85,000 K. Maintenance cost will become 55,000, and then the road user cost per year will become 2,000 K. Okay, let's see the solution. Alright, so the first step to do is to develop a cash flow diagram. Alright, we have the 4-line basics for Kuala Lumpur, Kuala Pilah, Muazzam, and Kuantan Road. We call those as N route here. Okay, N route here. So the initial cost will become 90,000 K. Alright, this is the present value today. And then we need to pay maintenance cost 100,000 here yearly, and then 1,500 K, okay, each of those, okay, for 30 years. All right, and then for 4-line basic road without toll for Kuala Lumpur, Kuala Pilah, Leban Condong, Pekan, and Kuantan, we call this route as S route. Okay, S route here. So the initial cost will become 85,000. Okay. Okay. We need to pay for the initial cost today, 85,000. And then the maintenance cost will become 55,000 every year for 30 years. and road user cost per year is 2000 yearly, okay, for 30 years. And then due to annual cost A of N, okay, N here is lesser compared to S, okay, what is the A per N root, okay, the A per N root here is around 1005 plus the 100, so they become 1600, okay, K, all right. And the S line or S root will become 2050, okay, K, all right, 55 multiple with plus with 2000. So N root, the A here is lesser, okay, is lesser compared to the S root. So the calculation we will start with N deduct S, okay, N deduct S. Alright, so we develop a second cash flow diagram based on N deduct S. So we will have 1500 minus, okay, deduct 2000, we will get minus 500k, and because of negative value, the arrow was reversing from downward to become upward. All right, and we also have another calculations here. 100, okay, deduct 55,000, okay, so we get 45k, and because of the positive value, the arrow will stay downward. All right, this is the easier case. All right, after we got the cash flow diagram, we construct our BCR based on N minus S. Okay, so in our calculation here we have 500, okay, divide by 5000 multiple by finding A when you knew the P, okay, at 5% for 30 years. Why this? Because we calculate this based on per annum calculation, okay, per annum calculation. So of all future value, of all P value, we need to change it to become per annum. So in our case here, 5000 is our present value, so we convert it to become finding A when you knew the P. What is the P? P is our 5000 here, okay, plus 45. 45 is in per annum value, no problem. 500 is also in our per annum value. So once we got this understanding, we just calculate, and then we will see that the BCR and deduct S is 1.35. So our understanding is for each ringgit spent by our government for project N, public will benefited 1.35 ringgit, which is more than value of 1. So project N is worth it, should be accepted and constructed. Choose project N. Alright.